Okay, hello, thanks for coming. I'm Germán. I'm a founder of EVM. I'm with Kevin, also founder and CTO. EVM is a solution to make virtual blockchains on any chain with smart contracts. With this, we can get stablecoins, private, and compliance on Ethereum. So basically, what can be done today on EVM? Chain compliance. Ethereum as a whole can't be compliant because there is many different solutions and applications, and it's of course decentralized and permissionless. Token incompatibilities. X402 is an example where we need to wrap tokens to use them, or we have to deploy new ERC20s. There is complex privacy solutions. Everyone is bringing privacy in a different way. So we have to adapt to each solution to add privacy to our application, or develop our own privacy solution. Nonce illogics. To do something today on Ethereum, we have to follow a sequence of nonces. We have to wait one transaction to be complete, to send another, and all the things that brings more problems than solutions. Gas and account abstraction is a thing. We are thinking, okay, how can we solve this gas thing? So this new EAP to apply to some tokens. So there is a paymaster, and you have to implement it, and this and this and this, and security issues came up all the time, and there is treasuries that are completely empty from one day to another, and account abstraction, of course, that needs to follow standards and implementations, and of course the multi-chain composability with the liquidity and all these things. So EVM solves all the things, and we think is a future for stablecoins and agents. With an EVM, that is a chain that is completely emulated with smart contracts that are deployed on-chain. So it's an infraless solution, and of course it's open source and free to use. You have a gasless UX, because everything that goes inside these contracts that we will see later are intents. The user can go permissionless and also interact with these contracts like a virtual RPC. The main contract, the core contract, acts as an RPC, but it's on chain, or can send the transaction through any relayer. That doesn't matter who is, but we can make sense to who is if we want to have virtual sequencers as well. But now in the basic configuration, doesn't matter who go to send this transaction, and the intent is executed inside by the EVM logics that we configured just in Solidity. There is infraless, so we don't need infra to have an EVM. We deploy this on Ethereum mainnet, or in Base, in Arbitrum, anywhere. We deploy these contracts, and we have our private environment there. We don't need to ask permission to anyone. It's full composability, so we can interact from the EVM. No, anda para atrás. No, para el anterior. We can interact from the EVM ecosystem. So this is like a world blockchain, layer 1, Ethereum, Base, whatever, and we are inside the blockchain with contracts, so we can access all the protocols that exist there from inside to outside. To go inside these protocols to our EVM, we configure the permissions, where in the contract of the core that lets every address interact inside or not. There is secret privacy and a full homomorphic encryption confidentiality already developed inside. These are services, are modules that anyone can code. It's just following the schemas of interaction and the signatures inside, and then you can have your own services, is how we call that, are other smart contracts that are part of the ecosystem. These smart contracts are deployed on the host chain, but are admitted to interact by the rules that we configure that are very simple inside the EVM to have a composability inside. The X402 payments are native. We have a AAP 8004. You can KYC or AML a whole EVM. This means that you can apply any KYC protocol or system to your EVM, and only addresses that are already past this KYC will be able to interact inside. So now you have a compliance ecosystem on Ethereum, for example, if you are a banking institution. And async nonces that are something very interesting that we have is that now the transactions doesn't have to follow a sequence also in Ethereum, in L1. This is very useful if you want to make, in example, DeFi orders, or you want to sign some payments for your agents, like vouchers, and are not going to be used now, are going to be used in the future by following some rules. Okay, these vouchers are valid, and some execution can go before, after, and doesn't matter the order now for this. You can still use in sequence if you want to have a logic that depends on sequence, but it's not needed. Okay, we'll go. We don't have a timer. I don't know. Okay, I will check on my phone. Okay, so basically what I was talking before, you have the EVM ecosystem, you have here a stable coins, you have a market condition here, you have all the access to go outside. You can also delimitate the military zone, or you can say, is everything open? And for go inside the EVM from the ecosystem, you can say it's open or closed. And the transactions can go directly to the EVM from the users, or they have to use relayers, or you can block the users to interact, and we will see it later. So now, with this, you convert any blockchain into yours, because you are keeping a part of this L1, Ethereum, whatever, for you, just deploying contracts. You are using their infra without paying infra necessary charges, and you will inherit all the security. The execution will be happening on the nodes of the blockchain that you are deploying to, the normal execution, and you are subject to their consensus. But inside, you can have your own logics of execution. The state is completely yours. The state resets to 0 when you deploy an EVM. And the consensus, you can do also some sharded consensus if you put some relayers as sequencers of your private network. That is a configuration that you can easily do also. So we go. So this is a very common use case that we are working on. Is banking and stablecoins. With the EVM, what can happen now is that a bank can deploy an EVM or a financial institution on mainnet, make a compliance, tell for the institution that is needed to be compliant to, okay, our users paste a KYC AML, so everything that happens inside here is safe, so we can deploy a CK Vault there. So you can make a Tornado Cash for your users to make transactions between them, because they are good people, we know where the funds come, and we want to add privacy for all of them. And at the same time, all these users can interact with the whole ecosystem. They will be able to use Aave, Uniswap, and any other protocol for yield generation from inside the EVM. Also in a gasless experience, if you want to sponsor the gas, because it's native, this possibility. And then, well, now banking can interact very freely inside Ethereum in a controlled environment for audit reasons, audit matters, and well, this is very auditable by any agency. So we go. This is a little of inspection of what is the CK VVM, that is this module for CK. So we had Vitalik saying some things about the privacy for the weak, transparency for the powerful, privacy for individuals, transparency for organizations. How this is solved with just an EVM. We go. You have native composability between all the different institutions as well, because there could be an EVM from one bank, another financial institution living on the same ecosystem, Ethereum L1, for example. The users will use CK Vaults and full homomorphic encryption for transfer between them, or CK Vaults for privacy completely, not only confidentiality, who is, also privacy, where these funds are going. We're going to see a demo video where we are using in Sepolia now a CK Vault to send payments and split them and all these transactions without knowing who is interacting. And they can KYC, AML, and do other compliance for the EVM that they are deploying. This is a a simple workflow, how it goes. I'm a user. Okay, this is an EVM 1 from a bank. This is a EVM 2 from another bank. The user can go directly to the EVM or can go through a relayer. Doesn't matter. Okay? But here is the KYC gate that is inside the EVM. So the user can't go directly to interact with the CK Vault or anything. They have to go all the way through the EVM because this is how it's coded. It's just Solidity. So also you can fork and make your own changes, and it's very, very, very easy to change also because Kevin made it very, very well coded and very well documented. Also, we have tons of pages of documentation, and we have also an LLMS TXT docs for agents, so you can load this into any agent and become a senior developer of EVM. So you go through here, you check the KYC for this user address, and if it's okay, they can interact with the CK Vault and all the different services that the bank deployed for them. And from here, also the user, when comes here, he can interact with Aave, Uniswap, or other banks as well. While the bank, to interact with other banks, they have to be public. So here we have the privacy for our users, our bank customers, and between institutions, we have public information. Okay, to just be a little deeper, when there is a registration, you can do the KYC okay, or you are denied. It's just these simple logics. It's not extremely complex algorithms. Then when you want to deposit, if KYC is 0, no. If you have the proof, okay, this is for, okay, sorry, this is for the CK transfer already. If you want to do a CK transfer, you want to deposit it. If you have the KLC LML denied, you go out. If not, you get a 1, you are okay. If when you want to deposit, if you have a 1, you go. If not, you go out. Then you have the proof. And when someone wants to withdraw this, that is the privacy transfer, if they got the wrong proof of it's not authorized, another is authorized with the right proof, doesn't matter, it don't get it. And if it's true, they can redistribute or they can transfer to make a withdrawal inside the EVM. Okay, we go. What we used to foresee was the EVM with a small changes, NER, ACVM, and CK circuits, ultra-plonk, ultra-honk proving systems. So, ¿tenés el video ahí? ¿Lo tenés en la computadora? Okay, we have a video. In the meanwhile, or we can make a live demo if not. Why EVM is cheaper and it's an option and it's interesting? Well, a traditional blockchain or L2, you need validators, nodes, and DevOps. Here you have 0 because you inherit from the host. You have to be just very, very aware of which host are you considering for this? Are you going to use? Deployment time, traditional blockchain, 3 to 12 months. In EVM is 1 command, could be 1 minute, and you have it. We have a CLI deployer. You will have a QR code at the end of the presentation where you can access all our code base and our tools, or evm.info. You go there and you get all the docs. Initial cost, 500K, 2 million. This doesn't matter. It's a lot of money, a lot of time also. So it's important, but could be even more. And here is just your customizations on your EVM. We remember that we choose where we want to deploy. This is very important because when we choose where to deploy, we are inheriting all that infra. And that is a reason to choose maybe Base, maybe L1, maybe Arbitrum, because why we want to do this and which are our customers. Okay, we go and we get into that ecosystem with our own rules. Securities, we inherit also the security from the chain where we are hosting. So our security is involved more in our change to the EVM code that is already audited. So if you make change, you need to re-audit these changes. And on the gas for users, the user has to have gas in any chain, unless there is some program or promotion that now someone is paying for this gas. In the EVM is always abstracted. So it's up to the deployer if you want to help your users or not as a deployer itself. And also there is a tokenomics implemented, so you can use that tokenomics to reward the different users. This is a little of progress because this seems like a new project for most of you. I don't know who here knows about EVM before. Who knew it? Okay. Well, there is traction. There is devs working on this. When you deploy using our CLI, you are not offered to deploy on any production chain or our testnets, because we are finishing our first big audit, and we think this stamp is needed. Also, someone to really formally check our code before putting someone in trouble. But it works pretty good for any testing. There is an example for CK. There is a X402 paymaster required middleware. So it's interesting. Like in EVM, we don't need to do any wrapping of token on any adapter for paymasters to use it and be compatible, because we already have it. The EVM is abstracted. You can give vouch to anyone to execute the transactions, but also inside the signature, you sign for who is the origin address that is going to execute this. So you can limit one transaction to be executed just by one external owned account, or you can also limit it to a message sender. So your transaction only can be executed by some on-chain contract as well. And this opens a lot of possibilities. This was a configuration from the beginning, because with the EVM, when you abstract, you can do a lot of improvements and very easily. So we are X402 compatible from beginning. We just had to make the schema for the middleware. Full homomorphic is also integrated in some implementations. And well, you can do more also, the next ones. So we think, like happened on internet, that on the first we have the dedicated servers, the metal, you know. Then virtual private servers came, and we start sharing this metal, these resources. There was a lot of bugs, a lot of problems, people abusing from the RAM on the server, the CPU, and all these things. Then the software became better, but sharing the infra is something that is natural, and we are not doing that on blockchain now. Orbits are not a solution for us. Subnets neither, requires staking, deployment of more infra. L3 is the same. So let's share the resources that we already have, adding software, adding optimized software, and continue doing it. So this is Ethereum, this is any chain, this is an ecosystem, and we can have a banking BVM, we can have the KYC BVM, agent, yield generations, new EAP BVM, and we are working now in a quantum-resistant EVM. And why now, and why it matters? Because for us, it's very important also to prove that with just a few solidity lines of code, we can add quantum-resistant signatures inside the EVM for checking, and this makes all the whole ecosystem of the EVM deployed on Ethereum quantum-resistant natively, and with the current protocols, abstraction, they can interact with the rest of the ecosystem. And this will be ready in 2 months. And in the plan of Ethereum itself to upgrade to this, it's like 2 years, 3 years. So this is a capability of the EVM. If you have some change on Ethereum to make, and you think, I want to make it now, and I want to make it better, you just do it in Solidity. You can think it's an emulation, it's working, could be not optimized on gas cost, depend on your ability, but you are able to do it with this. So here is an image with a QR code, but it's not loading. But this is the talk. We have, Kevin, do you have the, no, it's okay. Do you have the video? Okay. We will see this video demo and we finished. In the meanwhile, anyone has some question? We are going to see live the CK bolts working. There is any question in the middle?
A couple of questions. How do you I have a question, like how do you scale like transactions with this network, or like build in, for example, in top of Ethereum?
Scale?
Yeah.
Well, this is very interesting. What we do for scaling at this stage, that is at small stage, we added a functionality inside the EVM that you can send a bulk of 20, 20, 30, 50 transactions. I think we limited because the block limit. And these 50 transactions, if you send as a bulk, consume less than sending 50 transactions on Ethereum itself. So this is an optimization. It consumed less gas to send 50 transactions together to the EVM than to send the same on Ethereum. Why? Because of the logic of how the accounts are optimized and how the accounts state changes transaction by transaction on Ethereum, and we manage everything with mappings. Just one transaction will update the nonce and the ETH amount state on Ethereum itself. But you can do sharding execution. You can add your own relayers and push the users of your EVM to use your own relayers. So then you do some sharding execution. You can use some Merkle tree for proving transactions and the state of the chain, and then you scale even more. But you are adding a little infra. So this is very fast. Please, Kevin, you can explain.
Yeah, I'm going to be very quickly. So we're now deploying an EVM using our CLI. So it's pretty quickly. I'm going to skip some parts, and you can see it's like 3 minutes, less than 3 minutes, depending on the internet connection. And after this, it's just simple. You deploy in your CK service. So you need to do all the info for preparing your deployment. It's like 1 minute. It's pretty quickly too. So after this, you have all deployed, and you can test it out right now. You can use this commitment. So we make a deposit for 20 USDC. We are signing off the transaction for the EVM with all the commitments needed to execute that. So they make the deposit, and that's it.
Okay,
so,
sorry guys, but we are running out of time, so you want to close with one sentence, really quick, and that will
Yes, this is finished in 10 seconds, so maybe you can finish just this, Kevin, show the result. You can fork this, it's in our repo, you can just deploy very easily. Everything is open source. Go to evm.info or catch us. Show the finish only? Okay.
Yeah, it's making the finish. So as you can see, it's pretty quickly. If you need more information, if you want some answers, you can go to evm.info, use our LLM TX, or go to the GitHub to fork all the projects.
Well, thank you. Any question? We are going to be outside. Thank you.